Previously, we have already gone through indeterminate forms in limits L4, and we have 7 indeterminate forms of these types, while limits L4 में हमने 0 by 0 form, limits L5 में infinity by infinity form, and lastly limits L6 में 0 into infinity type देखा. We also know that the first 2 forms are called fundamental indeterminate forms because the remaining 5 indeterminate forms are converted into the first 2 fundamental indeterminate forms and are then solved by using L'Hopital rule. Now आज के इस वीडियो में हम indeterminate forms of the type infinity minus infinity देखेंगे. The limiting form limit x approaches to a fx minus gx is said to be indeterminate form of the type infinity minus infinity if limit x approaches to a fx is infinity and limit x approaches to a gx is also infinity as well. Then we say that this form limit x approaches to a fx minus gx assumes the indeterminate form of the type infinity minus infinity. One would think, why isn't infinity minus infinity 0? Well, it isn't so because infinity is not a number, but infinity is a symbol which denotes an exceptional value which we don't know exactly. Infinity minus infinity 0 तब होता जब हम exactly ये बता पाते कि हम कितने में से कितना निकाल रहे हैं. But here we don't know that exactly. Now again, if infinity minus infinity was 0 or any other determinate form, then that again invites the discussion whether we can compare between infinities or not. Historically, George Cantor was one such mathematician who did compare between infinities when he postulated that set of natural numbers is equivalent to set of integers. And logically, his statement was supported by Hilbert's paradox of Cantor and mathematically by defining the bijective function from set of natural numbers to set of integers. Also, if we argue differently with that the difference of the set of infinite whole numbers with the infinite natural numbers leaves only one whole number behind, that is 0, and the difference of infinite set of integers with the infinite set of natural numbers leaves the infinite set of non-positive numbers behind. Hence, the difference between any two infinities is not uniquely determined. It can be 0, positive, negative, any real number, or infinity as well. So now then, infinity minus infinity is an indeterminate form. So we reduce the indeterminate form limit x approaches to a fx minus gx into 0 by 0 form by the following relation. So we write f of x minus g of x as 1 divided by g of x minus 1 divided by f of x whole divided by 1 over f of x into g of x. So if we take the limiting value, then this will be reduced to 0 by 0 form because 1 divided by infinity will be 0, 1 divided by infinity will be 0, so 0 minus 0, that will be again 0, and 1 divided by f of x into g of x, which will be again infinity, so 1 by infinity will be 0, so this is reduced to 0 by 0 form. And we do have a simpler version of this result as well. When fx and gx are both rational functions, they are reduced to the common denominator in order to convert them into 0 by 0 form. So चलिए कुछ examples देखते हैं, and our first example goes like this. Limit x approaches to 0 cosec x minus cot of x. So पहले चेक करते हैं कि indeterminate form of the type infinity minus infinity है या नहीं. So when x approaches to 0, so this will be cosec 0. Cosec 0 is infinity minus cot 0. Cot 0 is infinity. So this is of the form infinity minus infinity. So in order to solve this, so we'll be first of all converting it into 0 by 0 form. So here we'll be doing so by reducing it to common denominator. So in order to reduce this to common denominator, so we can write this as limit x approaches to 0 cosec x को हम ऐसे लिखेंगे 1 by sin of x minus cot x को as cos of x divided by sine of x. So यहाँ पे भी sin x and here sin x as well. So this can be reduced to common denominator. So this will be limit x approaches to 0. So sin x and sin x as common denominators. So it will be sine of x and upper 1 minus cos of x. Now checking for the indeterminate form of the type 0 minus 0. When x approaches to 0, cos 0 is 1. So it will be 1 minus 1, that will be 0. Sine 0 is 0. So it will be 0 by 0 form. So that means we'll be applying now L'Hopital rule. And L'Hopital rule में हम differentiation करते हैं numerator की अलग से और denominator की अलग से. So we'll be differentiating numerator and denominator. So 1 minus cos x की differentiation minus times minus sin x divided by sin x की differentiation cos of x, and minus into minus will be plus. So it will be limit x approaches to 0. So sin divided by cos, that is tan. So it will be tan of x, and we'll be having tan of 0 as 0. Now the second example is limit x approaches to 0, 1 minus x minus cot of x. So this is again infinity by infinity form. So we'll be again reducing it to common denominator. So we can write it as limit x approaches to 0, 1 by x as it is, minus cot x को as cosec x divided by sin x लिखेंगे. So in order to reduce this to common denominator, so we'll be here cross multiplying. So we'll write this as limit x approaches to 0. So sin x ऊपर multiply sin x minus x का यहाँ multiply. So it will be x cos of x divided by x into sine of x. Now when x approaches to 0, so this will be sine 0, which is 0 minus 0 into 1. So it will be 0, 0 minus 0, which will be 0, and again this will be 0. So this has been reduced to 0 by 0 form. So therefore we'll be again applying L'Hopital rule. So this will be limit x approaches to 0. So ऊपर differentiation of the numerator divided by the differentiation of denominator. Sin x की differentiation cos x minus, so x cos x की differentiation minus x sin x plus cos of x divided by x sin x की differentiation x cos of x plus sin x, which will be limit x approaches to 0. So cos of x minus, so this will be cos of x minus into minus, which will be plus, plus x times sine of x, and minus into this plus, this will be minus cos of x divided by x cos x plus sin x. So this cos x and cos x will cancel out. We'll be arriving at limit x approaches to 0. So it will be x sin x divided by x cos of x plus sin x. So this is again indeterminate form of the type 0 by 0. So that means we will be again applying L'Hopital rule. So when we again apply L'Hopital rule, we will be again differentiating numerator as well as denominator. So which will be limit x approaches to 0. अब x sin x की differentiation, so it will be x cos x plus sin x divided by x cos x की differentiation minus x sin x plus cos of x plus sin x की differentiation cos of x. So which will be now x cos of x, so it will be 0, again 0, 0, but this will be 1 plus 1, so we'll be left with 0 divided by 2, which is 0. The next one is limit x approaches to 0, 1 by x square minus 1 by sine square x, and this is again an indeterminate form of the type infinity minus infinity. So we'll be again converting this indeterminate form into 0 by 0 form by reducing it to common denominator. So in order to reduce this to common denominator, we'll be cross multiplying again. So sine square x का ऊपर multiply, so it will be sine square x minus x square का ऊपर multiply, so it will be minus x square divided by x square into sine square x, which can be also written as limit x approaches to 0, sine square x minus x square divided by x square into 1 divided by sine square x. So x square into sine square x will be same as this step. Now we'll try to reduce few steps here. So we'll multiply here by x square and यहाँ फिर से x square का multiply करेंगे. X square and x square will be again cancelled out and we'll be left with the previous step. So we have done so in order to accommodate this step. So this will be limit x approaches to 0 sine square x minus x square divided by x raised to power 4. X square into x square, it will be x raised power 4 into, we know limit of product is product of limits, so we'll be distributing the limit, so it will be limit of this thing into limit of this thing. So it will be limit x approaches to 0 x square divided by sine square x. Now we can write this limit as limit x approaches to 0 x divided by sine x whole square, which can be again written as limit x approaches to 0 x divided by sine x whole square, and this is equal to 1. So this will be 1 square into 1. Now we can write this as limit x approaches to 0. So this will be sine square x minus x square divided by x raised to power 4 into, this whole thing will be 1 because limit x approaches to 0 x divided by sine x whole square, this is equal to 1 square which is 1. ये चीज़ें हमने पहले ही लिमिट्स L3 में डिस्कस की हुई है. So this will be now sine square x minus x square. So when x approaches to 0, so this will be sine 0, which will be 0 minus 0 square, which will be again 0 divided by 0. So this is reduced to 0 by 0 form now. So that means we can apply L'Hopital rule. Now we will be applying L'Hopital rule. So it will be limit x approaches to 0. So differentiation of numerator is sine square x की differentiation twice sine x into cos of x minus x square की differentiation 2x divided by x raised power 4 की differentiation 4x cube, which can be further simplified into limit x approaches to 0. So we know twice sine x cos x is sine 2x double angle formula minus 2x divided by 4x cube. So this is again indeterminate form of the type 0 divided by 0. That means we'll be again applying L'Hopital rule. So we'll be differentiating numerator as well as denominator separately. So sine 2x की differentiation twice cos 2x minus 2 divided by 4x cube की differentiation 12x square. So this is again 0 by 0 form, which means we'll be differentiating numerator and denominator again by L'Hopital's rule. So which is limit x approaches to 0. So 2 cos 2x की differentiation, it will be minus 4 sine of 2x sine of 2x minus 2 की differentiation 0 divided by 12x square की differentiation 24x. So this is again indeterminate form of the type 0 by 0. So that means we'll be again applying L'Hopital rule. So this will be limit x approaches to 0. So this will be minus 8 cos of 2x divided by 24x की differentiation 24x is 24. So it will be minus 1 by 3 into cos of 2x when x approaches to 0. So it will be cos of 0 and cos of 0 is 1. So which is minus 1 by 3. The next example is limit x tends to 0 pi divided by 4x minus pi divided by 2x into e raised power pi x plus 1, and this again is infinity minus infinity form. So again, in order to reduce this into 0 by 0 form, so we'll be taking the common denominator. So we'll write this as limit x approaches to 0, but here we have pi by 4, यहाँ पे pi by 2, so pi by 2 common निकालेंगे, so it will be pi by 2. So we'll be left with 1 divided by 2x minus 1 divided by x into e raised power pi x plus 1. which is limit x approaches to 0 pi divided by 2 अब cross multiply कीजिए in order to reduce it into 0 by 0 form. So it will be x into e raised to power pi x plus 1 minus 2x divided by 2x into e raised to power pi x plus 1. नाउ नेक्स्ट यहाँ पे x एंड x नीचे भी x, सो अगर हम x ऊपर कॉमन निकालें और नीचे x, सो दैट मीन्स दिस x एंड x विल कैंसल आउट, सो वी विल बी लेफ्ट विथ लिमिट x टेंड्स टू 0 पाई बाई 2 इंटू ई रेज टू पावर पाई x प्लस 1 माइनस 2 डिवाइडेड बाई 2x इंटू ई रेज टू पावर पाई x प्लस 1, which can be further simplified into pi divided by 2 into limit x approaches to 0. So it will be e raised to power pi x plus 1 minus 2. So this will be minus 1 divided by 2x into e raised to power pi x plus 1. So this is now indeterminate form of the type 0 pi 0. So that means we will be applying L'Hopital rule in order to solve this limiting problem. Now we can write this as, so pi by 2, ये 2 फिर से बाहर आएगा, so this will be pi divided by 4 into limit x approaches to 0. Now differentiating numerator and denominator, that means applying L'Hopital rule, so it will be e raised power pi x की differentiation pi times e raised to power pi x divided by x into e raised power pi x plus 1 की differentiation by product rule. So x as it is e raised power pi x plus 1 की differentiation pi times e raised to power pi x plus e raised to power pi x plus 1 into x की differentiation 1. So this will be pi by 4 into, now I guess the limits can be used, so it will be e raised to power pi times e raised to power pi into 0 divided by x goes to 0, so this will be, this whole thing will be 0 plus e raised to power pi into 0 plus 1. So it will be pi divided by 4 into, so this will be pi, and this will be e raised to power pi into e raised power 0, so this will be 1 plus 1. So it will be pi square divided by 2 into 4, so it will be pi square divided by 8. Now the last one is limit x approaches to 0, 1 divided by x into 1 plus x minus log of 1 plus x divided by x square. Again infinity minus infinity form hai, so that means we'll be again converting it into 0 by 0 form. So we'll do so by reducing to common denominator. Again common denominator में लाने के लिए we'll cross multiply, so it will be x square का ऊपर multiply x square minus, so it will be x into 1 plus x into log of 1 plus x divided by x into 1 plus x into x square, which is limit x approaches to 0. ऊपर अगर हम x और x common निकाले, then that will be cancelled with this x, so we'll be left with x minus 1 plus x into log of 1 plus x divided by ये x cancel हुआ, so it will be 1 plus x into x square. अब x square का multiply करेंगे, so it will be x square plus x cube. So this has been reduced to 0 by 0 form, which means we will be applying L'Hopital rule. So it will be limit x approaches to 0, so x की differentiation 1 minus 1 plus x into log of 1 plus x की differentiation by product rule. So it will be 1 plus x as it is into log of 1 plus x की differentiation 1 divided by 1 plus x plus, so log of 1 plus x into 1 plus x की differentiation, so it will be only 1 divided by x square की differentiation 2x plus x cube key differentiation 3x square. Simplifying further, so we'll write this as limit x approaches to 0 1 minus 1 plus x से ये 1 plus x cancel होगा, so it will be 1 minus 1 minus into plus which will be minus log of 1 plus x divided by 2x plus 3x square, which is 1 से ये minus 1 cancel होगा, then this will be minus log of 1 plus x, so this will be minus limit x approaches to 0, so log of 1 plus x divided by 2x plus 3x square. Now फिर से अगर चेक करें, when x approaches to 0, so this will be log of 1. Log of 1 is 0 divided by 2 into 0 plus 3 into 0 square. So it is again 0 by 0 form, which means we'll be again applying L'Hopital rule, which will be minus limit x approaches to 0. So log of 1 plus x की differentiation 1 divided by 1 plus x divided by 2 in 2x की differentiation 2 plus 3x square, which will be 6x, which is equal to minus. अब limiting value use कर सकते हैं, so x approaches to 0, so this will be 1 divided by 1 divided by 1, or 2 plus 6 into 0, which will be only 2, so it will be with reciprocal 1 divided by 2, which is minus 1 by 2.